Right, here we go with the next project, and this is going to use the Raspberry Pi Zero and an H-bridge. So this is hacking a remote control spider thing. So we've got underneath space for 3 AA batteries, giving us 4.5 volts max, and that powers one motor there, which is for one side, and then under here you can see you've got another motor there. So you've got 2 DC motors, each controlling the left and the right side. So I'm going to take the screws off at the bottom so you can see the mechanism. So this I thought was perfect for making a Raspberry Pi robot from, because we've got 2 DC motors, we've already got the housing for the batteries, so that's going to be nice and neat there. We've got some lights as well, which I'm going to try and reuse. There's some lights there in the front of it as well, so I'm going to try and put some lights back in there, or reuse them I should say. Maybe I might be able to put the Raspberry Pi Zero on the top somewhere, even in the body cavity, but there isn't much clearance on the bottom either, so what I might try and do is sort of raise it up a bit. Spider on stilts somehow. But I'm going to take this off the top here, these wings and things off the top, and put the H-bridge, because I've got a very simple H-bridge that I'm going to attach to this, which is a couple of quid. I haven't got one of the ones which plugs straight onto the GPIO pin, so I'm going to use what I've got, but I'm going to try and hack this to make it just walk. So literally it's just going to be able to either walk forwards by turning both motors on, backwards by turning both motors the other way, or turn left and right by changing the signal to the GPIO pins. So it's going to be quite a nice little project actually, to use one of the Raspberry Pi Zeros that I've had for most of the year and done nothing with. So yeah, so what I'm going to do is take the screws at the bottom. We've got 4 screws there, and have another look at the mechanism in a minute. Right, here we are. I've taken the screws out the top. So we've got, this is the top of it here, and there's a grey wire that's looped around. So I'm just going to snip that because I believe that's the aerial. Don't need that. And then if I lift it up, you can see there's a set of legs and mechanisms either side, and gears hiding just under there. And on the top you've got the original receiver unit, and presumably, not an expert, but I'm guessing there's an H-bridge built into that already, into that circuit board. If I was an expert I'll be able to reuse that, but I'm going to use one that's I've got already. So you can see by, if I just show you, by turning these cogs here, you can see the mechanism, and this is just one of the motors at the back, so it's perfect for an H-bridge and 2 motors. So what I've got to do is to take this receiver off, because it's obviously had a little transmitter, little hand transmitter, which has since gone. This was a charity shop find for a couple of quid. So I'm going to take off all of that, keep as much wiring as I can with the 2 DC motors. So there's one, you can see there's the brass cog from the top of that first motor, and again if I just run that by hand, you can see the cogs already doing the work. So I think this is going to look pretty cool actually, driven by a Raspberry Pi Zero, and using a battery pack that's already underneath. So that's what I'm going to take off there. Now off the top here, and take this little cannon thing. So obviously there was a mechanism in there which actually fired things out this little cannon. So that might have been quite cool to keep it, but and get that sorted. But that's beyond the time. I want to get this sorted in about a week, just to get an idea of what you can do with a Raspberry Pi hacking remote control cars. So I'm going to take all those screws out, and that'll remove this sort of top thing there, this old cannon and the wings, and that'll be the perfect place to put the H bridge. And maybe, looking at how much room I haven't got in there, I might be able to get a Raspberry Pi Zero in there, although it's looking, no, I don't think so. So it's all going to have to sit on the top, which will look cool, actually, look fine. So the Zero and the H bridge are going to have to sit on the top there, with some lights at the front and the back, which are going to be powered off the pins. So we'll come back when I've done a bit more fettling on it to get that receiver taken off, and start to get the batteries wired up to the H bridge as well, so I can get all that sorted. So that's the next plan. So I'll try not to disturb too much of that, because I don't think I'll need to, because all I need to do is to find the two wires which come from each of the motors and make sure I can connect those up to my H bridge. So I need to sort of take all this wiring off here, this loom, very carefully, and make sure I can get to the wires which power the DC motors. There's two wires for each. So that's the plan, is to drive this thing using Raspberry Zero, Raspberry Pi Zero, and just a cheapy H bridge I've got as well, and see how it all runs. And some LEDs in the front and back of it. Right, I'll be back later. Now, I've had a bit of a tear down, as they say, dismantling. So we've got the bottom case where that covers the 3 batteries. That was just sort of gun on the top, couple of wings. Those are the covers at the front. These were this is the remote control receiver unit that was on the top there. I've taken this grey wire was all wrapped around the inside of there, so we've now got this, which is the top cover, so that'll be perfect for Raspberry Pi Zero and mounting the H bridge on there somehow. Now that leaves us with 3 wires here, 2 of which are going to be powering the motor, and the other motor around the back we've got a bunch of wires here, because we've got the on-off switch as well for the battery pack. So what I'm going to do is to strip, rather than strip the wires off, because I'd like to take this top off here, because there's 4 screws that's holding this top plate on, but one of them's hidden under here. I can get that one. That one's easy. That one's obviously easy. So there's 4 screws that will hold this top plate on, and I could lift that up and get to the motors. But I've tried to prise this gear off and that gear off, giving it a tentative prise, but I think if I actually prise those off I'm going to damage it. So, and there's a whole load of coggage going on in there that provides this complex sort of walking mechanism. I think if I take that off it's going to be a world of pain, and I'll probably never get it back together. So the other alternative is to strip these wires back here and to find the 2, just get a 9-volt battery, and to literally do the unscientific method of actually just touching 2 wires at a time until I find the 2 wires which power each motor. So this side's going to be easier because I've only got 3 there, and then I can keep the on-off switch as well. So I'll need power going into, I need 2 wires going into the H bridge for the powering the motors, and I need 4 wires going to the output side of the H bridge, which will be these two and 2 over here, I think. So yeah, so it's a bit of trial and error, but it shouldn't take too long, I don't think, really. I think it's going to be a whole lot less hassle than taking this top plate off with these screws and trying to prise off these nylon gears, because I just think I'm going to damage it, and that'll be loads of work, and I'll just break it, I think. So yeah, so a bit of trial and error, and I'll come back when I've actually detected the correct wires. Right, so I've stripped some of the wires back, and luckily I guessed right. So what I've got here is a 6-volt battery pack, which is only 1.5 more volts than the 3 batteries that normally power it. So at the front I've got a couple of wires that I've stripped back. If I just touch the terminals of the battery to it, you'll see, there you go, that we've got power. So that's one side, and then the other side, I guessed that there was two white leads that were coming out either side of the motor. So again, if I'll strip those back, so these need to be tinned. So right, we've identified the inputs for the 2 motors, and so these wires at the back here, I've got a bunch of 4 wires. They're going to be controlling, 2 of those are going to be controlling the switch on and off for the battery pack, so I've got to identify those. This one at the front here is redundant, I don't need that one, so I only need to identify 2 of these wires, so I can actually use the switch underneath to switch the power off and on. So we're making good progress already. So what I'll do is I'll tin up these wires and connect a couple of these jumper leads to them. So these are normal jumper leads that I need to connect to the H bridge, and we'll show how we connect it to the H bridge and start moving from there. So I've had a bit of a go at soldering some connectors on. So I've got 2 connectors for each DC motor, and these are the ones that are in this H bridge. So this is the H bridge I'm using. So these are one motor one side and another motor the other side here. So this is what I'm going to use to power the motors, and then these pins here I'm going to plug into the GPIO pins of the Raspberry Pi. Couldn't get the battery pack working underneath for some reason, so I'm going to use an external battery pack here just to plug into the H bridge. So that goes on these 2 terminals here, one ground and one the current. So I'm just going to give it a quick go. I've got a quick setup there, like a test rig, and I'm going to see if I can just get it to work very quickly. Right, I've got it set up on the test rig. So I've got GPIO pins 2 and 3, 17 and 18 connected up to the H bridge there. So I've got scratch here, 17, 18, so when I press the up arrow, both motors go forward, down arrow, both motors go back, left arrow, one motor on, right arrow, the other. So up arrow, down arrow, left, right. So it works. It's quite scary, actually. So that's proof of concept. I've got an external 6-volt battery pack. It should only have 4.5 volts. So what I've got to do now is to get the battery holders underneath working. The switch wasn't working either, so I've got to get that H-bridge mounted and then a Raspberry Pi Zero put on the back there, but it works. So it's all good. So what we've got here is Raspberry Pi Zero. There's a power bank underneath, really cheap power bank for about £3. I got off eBay the other day. We've got Bluetooth dongle there, and we've got a H-bridge under there. I'm just seeing H-bridge. I've got it strapped to the top, and we've got the H-bridge is driving the 2 motors. There's one motor there, like I said earlier on. There's the other motor there. I've just wired the battery pack underneath, and there's a pin-out reference there. So essentially it's just got forward and backwards, and it can turn round. And my glamorous assistant Poppy is going to drive it. So we've got a little Bluetooth keyboard there. So if you want to do the forward and back for me, Poppy, and then the right and left, pick up the keyboard and then do forward and back. And spinning left and right. And the other way. Brilliant. What do you think of it?
Good.
So there we have a cheapy £2 toy hacked into a spider. It doesn't look very glamorous. I've got to tidy this up a bit really, but anyway, it works using a Raspberry Pi Zero there and a relatively cheap £2 H-bridged motor driver there. I have just bought a Ryan Tech H-bridge which I can solder directly onto this Raspberry Pi Zero, but I'm up against time a bit. I haven't got time to do that this week, but perhaps next. But if I could get a smaller power bank, it would look a bit more glamorous, but it works. That's the main thing. So try it again, Pop. And just stand up here so you can see it. So just do the left and right buttons for me. And spacebar. Brilliant. And last thing to say is I've just done that with Scratch, so the next thing to do is use the Rpi Zero library just to get those motors done in Python. And it's obviously running headless, so yeah, works a treat.
I'm gonna have to turn it on.